So I'm going to prepare this excavator to do some flow testing at the boom cylinder line. So I found a comfortable place as far as how to position this bucket, stick, and boom so there won't be drift happening. I won't drift through the door, and I won't have to worry about while I'm taking the lines off, anything coming down and drifting. And again, what I did is charged up the accumulator by running the engine, shut the engine off, put the activation lever forward, cycled all the controls in the cab till all the implements relaxed. I could hear oil discharging out of all the lines and cylinders until they're all depressurized. Then I kept going on the controls until I vacated the oil out of the pilot system accumulator. So now the machine, I'm safe to take any of these lines off, and I'm not concerned about them storing oil. I'm also just going to vent the cap on the tank just to keep it from being annoying in case it's trying to push any oil through the anti-cavitation valves into work ports. Then what I'm going to do next, just sort of a matter of course for testing inside the shop like this, if we're going to have an operator in the cab while we're doing some testing, I like to disconnect the swing brake line. When we talked about the swing system, we talked about that brake being spring applied and oil pressure released. So when we're using any implement functions in the cab, we'll be sending pilot oil to a relay valve on the side of the swing device, swing motor, and that will go in. Oil will then go in and release the brake. So all I have to do to lock the brake on in this machine, which we would also do for testing swing reliefs, all I need to do is take that hose off, put a O-ring face seal plug into the end of it. I'll leave the fitting on the swing motor itself open to atmosphere, and that way I know no pressure is going to be able to push on the piston and release the, or push up on the piston and release the tension from the discs and plates in there. So the springs will be holding the brake applied if I take the oil source away from it. So I've taken the supply hose off, and I actually took it off at the front of the control valve where the logic network actually feeds the swing brake release line. So I've taken that, taken the hose off of there and put a cap on to seal off where the pressure supply comes out of the valve. And then again, I need to avoid the temptation to want to plug off this hose. I'm going to leave this line open atmosphere. Otherwise, if I were to plug that line and it's full of oil, as this area heats up during testing, or if there's any leakage through the swing brake, what can happen is pressure can start to inadvertently build in this hose. So I don't want that to happen. I want to make sure there's no pressure at all. I want to make sure my swing brake piston is open atmosphere at all times, and therefore I'm guaranteed if any leakage does happen, I'll see it coming out this line, which wouldn't be great either, but it's better than having it inadvertently release the brake on me. So that way, having that vented, I know that I won't be able to apply the brake, or I won't be able to have the brake release on me. On a machine that has a solenoid and a solenoid operated swing brake, may be as simple as just pulling a connector, an electrical connector off of the solenoid to lock the swing brake on, but that's going to vary from model to model. But in essence, what we want to do is make sure that pilot pressure can't get to the swing brake to release it. That makes the machine a little safer to work on with two people in the machine, just because with pilot controls, the spring force on the control levers is so low that if someone was to inadvertently hit the controls and swing, that could be dangerous. So again, we've got all the pressure off the system. I've vented the cap. We've released all the pressure from the lines. Next step, I'm going to take these hoses off, and I'm essentially going to replace the boom cylinder hydraulically in the system with a flow meter. So what I'm doing here is taking the lines off of the boom cylinder connections here, and putting quick connects in. I'm putting the female quick connect on this end so it connects to the flow meter, and then I'll put a male quick connect on this line so it can connect to the flow meter here. So I've effectively replaced the boom cylinder now in the system with this flow meter. And when I do that, I'm going to lock these. These are locking quick couplers. I'll make sure that doesn't come disconnected while we're testing. So I'll misalign the pins from the notches. And now these can't be disconnected inadvertently. And then there's going to be a temptation to want to plug off these caps for the cylinder, for these steel lines. We're going to be a temptation to want to put caps on there and seal everything up all nice like we're taught to do. But here, in this case, we want to leave those again open to atmosphere, because if the temperature changes in this shop, the oil is going to expand in there, or retract, expand or contract, and that could change, put a vacuum on there if it contracts. But if the pressure builds up in there, if it gets warmer in here, then the oil expanding is going to make pressure against our caps. So we don't want that. We could put plastic caps over there just to keep dust and dirt out, and that way if pressure builds, the cap can just pop off. But the other thing that could happen is the operator could inadvertently move the bucket. And if the bucket moves, well, then the cylinder might move by default. And again, we could be building pressure in there. Then we get a situation where we got to remove a cap that's under pressure. We don't want to be doing that. So we'll put some plastic caps on the ports just to keep dirt out. So that's going to be basically getting us set up for doing the horsepower testing on the pumps using the boom circuit. I'm still going to have to hook up a tachometer. And then the other thing we're going to have to do for our initiation pressure test for boom 1 and boom 2 spools is I'm going to have to tap into the boom raise pilot pressure line and put a gauge in there. And there's a number of places you could do that on a machine. You could do it at, you could find, which pilot line goes down to which end of the cap for the boom spool for raising. The issue there with this one is when I checked it out, it's on the bottom and it's a little hard to get to. So it seems like the easiest place for this one's going to be underneath the cab at the pattern changer valve. So we're going to take this plate loose at the front here and just hinge it down, and we've actually put a if you can see it in there, we've actually put a quick connector on the boom raise pilot line where it runs into the pattern changer. So I've got the pan, I left the bolts in the back, took the bolts out of the front, the pan just kind of drops down here on the rear fasteners. And then in here, as you can actually see, there's a female quick coupler already plumbed into the pattern changer valve. So we're going to use this line with a male coupler to plug into that and hook up our gauge. So that gauge is hooked up, and I've just hung it in the cab here so the operator can watch that. So while the operator is going boom raise, partially or fully, they'll be able to see their boom raise pilot pressure specifically on that gauge. So same way we were checking initiation pressure going to the end of a pilot cap on a DCV, we're going to be checking our initiation pressure here, and that'll be important to figure out when we get one pump flow to our boom function and when we get two pump flow function to our boom function. We'll be able to actually see here, comparing it to where we get more than half flow to the boom circuit, and that'll tell us the initiation point of our boom 1 and boom 2 spools. And then I'm not locking out the boom offset, so I'm just going to flip that cover down over it.